Wait. Yeah, you take it, okay? You do it properly this time. I don't want a half presentation like all the other time.
Okay. Yeah, just like how I half solved G8. But okay. So the problem states can I see the so that there are so we need to show that A, B plus B to the A congruent is 0 mod A plus B. So first note.
That's not the question. It's like, are there infinitely many pairs?
Oh wait, but then but then so we first need to show that this is true, and then so for A and B. So then we note that.
On the screen. You can explain it clearly while I put this on the screen, okay?
Okay.
So there's infinitely many A and B.
Does it?
You can talk to them.
Yes.
Oh, okay. That's really cool.
What's it has text?
Yeah.
It's text. Okay, watch that.
What's it? Just have it. Alright, people online can see, right? So the question was, are there infinitely many pairs AB such that A plus B divides A to the B plus B to the A? Is that right?
Wait, how do I scroll? Actually, no. Well, I should do the other case first.
Usually, you should tell people what you're doing.
Okay, so case 1 is B is even because
what do you mean?
So we have to try to get rid of this term here because like we don't want to deal with that. So we have if B is even, then we have B to the power.
You're assuming it's true, no?
So yeah, so we split into whether B is even or B is odd. So if B is even, then B. So we will work backwards from the conclusion, and then this will just give B to the A. And then a exercise that can be left to the reader is proving that B to the B and this is left to the reader. So this is left to the reader to do it as an exercise.
You don't even know what the statement is.
It's true, but like,
what's the statement?
Yeah, that B to the B and A plus B are co-prime.
That's like.
Are you assuming A and B are co-prime?
Yeah, you did not need to say that is an exercise left to the reader. That's just obnoxious.
It's a really simple proof that I wrote down here, but like.
Yeah, it's just obnoxious. Like,
yes,
that is true.
I know.
Just say.
So this is case 1. Now we go on to case 2.
What? Okay.
Just trust what I'm doing.
Wait, what are you doing? Like, what's the conclusion of case 1?
Just trust me. Just trust me for now.
I'm not even sure what to trust.
Is this what it feels like when I present?
Yes.
It feels differently worse.
Okay, so then we get B to the A.
It's just like very legible.
At least he said exercise left to the reader. You're just like, this is like.
True.
So like, this is.
Okay, so then from here we can obviously get B to 0 mod A plus B, and it's just construct and then wait no.
You feel rushed or is it slow for you?
This is a bit slow. So, well, we define construction such that B to the power of just like M for something.
Are you showing it's true or that it's false? I feel like you should have started with that.
Okay, so then we need to find construction such that
I think that's what I
doing stuff. I don't know what he's doing.
Wait, do you get what he's doing?
He's trying to find the solution.
Yeah, so we need to somehow find a construction such that this is true, and then we can leave this as an exercise to the reader. But since I already know the solution, so I can just conclude that that the actual result is just 2p for some prime p, and then because of the fact that 2 and p are that they are co-prime for p is greater than 2, so then we get
oh shit, this is the part where like it's actually kind of tricky.
Like the funny, like if this was like ironic presentation to mock university lecturers, it would be very funny.
so then this is
like,
equal to
Are you
1
trying to
times
explain this to
That's
us?
what he was gonna do.
p minus 1, so this is equal to p minus 1, right? And then we just sum
Liam
these
has made
two,
his match.
huh?
Nah.
It's p minus 1, but like
At least I'm not going 100 kilometers and just doing it.
so
I
here
understand,
we
Ryan,
get 3p
your mind might
minus
work
1
very fast, but, like,
equals 2a.
You're writing.
It's
not legible at
Let me
that
check that.
Okay, so we get 3p minus 1 equals 2a, so hence a equals 3p minus 1 over 2, and then we also get b equals p plus 1 over 2 if I
What's
did.
P?
It's a prime.
Any prime?
Yeah.
When did P come into the
Oh, it is the construction here.
After he said this is an
Okay.
exercise left, he was like, but I know the proof.
He said there was an exercise left to read like 3
Sure.
times.
So we know that b is odd, so let
we've become readers now.
so then it is pretty obvious that since b is odd, then p must be congruent to 1 mod 4, right?
Yeah.
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 Imagine if he wasn't talking at all. It would have been
So then-
so much harder.
The Richlet's
You just write.
theorem
Uh,
states that
There's
In
infinite
In-
primes.
it says D
many
and it's a dot.
primes.
D
Okay.
is a-
There is no way A5 requires Dirichlet.
That's
Wait,
exactly
it's the
what
Richlet.
this is exactly what I did.
Oh my god,
It is
that's
the Richlet.
Like,
minus-
this is exactly what I did.
There isn't. It's
Okay,
Dirichlet.
except I didn't use the Dirichlet. I actually proved.
What did you use Dirichlet for? That this
Yes,
Infinite
that
primes
there's
are-
infinite primes such that p is congruent to 1 mod 4.
I think you could prove that directly. Like,
But like it's more fun just to cite
huh?
the theorem.
Well, proving was actually
The
kind
way,
of
trivialized.
the way I view it, like if you cite the theorem, you're kind of inserting the proof of the theorem into your answer. So like
It's like an include. It's like
yeah, like you're kind of like your nice answer, which is like a page, is now become 40 pages.
I get it.
But like I don't think we need to prove that. Yeah.
What?
Well, the infinitely many primes 1 mod 4 is a nice exercise.
Yeah, I
I
guess.
had to search this up though. This was hard. This is actually hard.
I read this in
Wait, you're not done, man.
Well, I am done.
Okay, now you have to prove
No one-
that there's infinitely many primes.
Oh, can you not put direction?
No,
Yeah,
I want
alright.
to prove it.
Now you
so,
must prove it as infinite primes.
okay, so I guess the thing you need to figure out is like what your purpose is. So is your purpose to communicate the proof, or is your purpose to explain your motivation? Is your purpose to like
Okay.
you know what I'm saying?
Yeah. So my motivation for using.
I don't care about your motivation if you don't want to tell us. I'm just saying
Okay.
like what
Yeah,
you just did.
I'm telling my
What-
motivation
what-
right now.
No. What you just did up to now, right?
Yeah.
Was that to explain the proof? Okay, so if it's to explain the proof, okay, it'd be nice if you told us what you were proving at the start.
Okay. Yeah. So
What is you?
yeah. So we were proving. Actually, we work from the. We first assume that it is true.
Yeah.
We first claim that this is true, and then we work backwards and then show that there are infinitely many p.
Oh, so you're saying the answer is yes, there are infinite.
Yeah, because by
It's like a very.
the Richlet.
You don't need to quote Dirichlet for
Well,
N5.
I feel like you
If
do.
you didn't quote it, then that was a bit concerned. But like, it is possible to prove this with more elementary methods.
Yeah. It is
Okay.
quotable, but like in very
Okay.
quotation marks.
So my inspiration for
I still really don't know what you did.
What is this?
Can I
something.
point something out? That was a construction. If the whole thing before was basically your inspiration.
So this is my inspiration for doing 2p because originally I was thinking about like just doing p, but then that doesn't work for obvious reasons because of by parity.
Yeah,
So this is incorrect. So then I just tried with 2p and then worked, and then yeah.
My
Okay,
original,
well, I have a slightly better motivation for that.
my original idea
Okay.
didn't work, so let's guess something else. And whoa, look, it worked!
Yeah, and then
Okay, my
the
original motivation for 2p was like I tried small cases, and some of them worked, and they were 2B. And I was like,
my other motivation was that because of the fact that this is true.
Maybe this is English speech giving advice.
Hence,
I feel like you've assumed the audience has already solved this problem. I think that's your.
That's what Liam does.
I don't think he even assumed the
He
audience.
assumes the audience is himself.
No, I don't even think he assumed the audience had already solved the problem. I think he just didn't assume there was an audience. Like, if there was, you were genuinely trying to present it to an audience, even if they've solved it, you would go slower.
Yeah, I feel like
He just wanted to get it out.
I feel like it's fine.
Can go to number 36.
No, we've already gone through number 36.
Wait, we have?
Yeah.
I'll send you the video.
Kind of.
Okay.
Okay, except that was a mistake, but.
Wait, so you're gonna get a lot of questions from this audience because this audience is not following what you're saying.
Okay.
So what is the logic?
So
Okay,
do
so
you...
you're saying there are infinitely many.
He just invented some random board.
This is why N5 took me so long, because I was trying to prove there was infinite points.
Yeah, so let me summarize this thing. So we first assume that a to the power b plus b to the power a is congruent to 0 mod a plus b. And so... Yeah, and then so the first step that we need to go here is we need to know the important fact that a is congruent to negative b mod a plus b. We need to obviously see why this is true. It's pretty trivial, and then we just subbing that here. So negative b to the power of b plus b to the power a congruent to 0 mod a plus b. And the motivation for considering the two cases is because because like negative 1 to the power n is yeah, so
I guess,
yeah,
I guess so the
that's my
case,
inspiration.
the case, it's not so much the motivation behind considering the two cases. Like having two cases there is explaining your motivation.
Yeah.
Yeah, like case one's not needed in the proof. That is your motivation for doing B is odd or something, right? Like so, it's not logically necessary. Right?
Maybe I can try to give motivation.
And then so we skip case 1 because that's irrelevant. So we go on to case 2, and then
so like we're logging B is odd essentially. No?
Yeah, and then we have to apply that at the end to make sure that we don't have like that says because like at the end I assume that that I have to factor in the fact that B is odd. Yeah, when considering that statement.
Okay. And then B.
I think you can log B as odd because if they were both even, then that's not good right. So that's basically what I was trying to find.
Yeah, because like here, just a full statement of this is b equals 2k plus 1, then times that by 2, that's 4k plus 2 minus 1, 4k plus 1, which is congruent to 1. Yeah, so...
No idea.
Alright, go up a bit. So I think you need to be more worried about losing your audience, you know what I'm saying?
Okay.
He lost his audience the moment he started going at that pace.
I think.
No, it's just the normal pace if you do a debate.
Not.
It can be not trying to debate. You're trying to.
Right. Are we doing a debate?
I'm used to doing debating. So
Are we doing a debate?
Yeah, this is a grant application where you're gonna make them not understand what you want.
No one is going to hear. How long do you think they can speak?
It depends on the competition. CAS is 4 to 5 minutes.
Oh, you're a debater.
Yeah.
Oh. That's
I
unexpected.
make like 8:30.
Oh, why?
Oh.
Debating is fun.
Oh, no, we're not done. We're gonna stay up there. Okay, so we got the B to the B plus. So B to the A equals B to the B mod A plus B. Is that in the case we're doing?
Yes, it's in the case.
B to the A
B
plus
is odd.
A to the B. Okay, and B is B is odd. Okay, yeah. Okay, and then B to the A equals B to the B. And then B to the A minus B equals 1 mod A plus B. Okay, good. And then you want something.
Stop banging.
Then you want N.
No, it's just a restatement of this. So just to make this easier for the reader to understand.
Yeah. Wait, so you want 5a plus b equal to a minus b?
Yeah.
Okay. You don't have to. Do you have to have that? You just if you have it, you win.
Yeah, because we have this to win.
Oh,
Yeah, we have
why
to have
not?
that. Yeah, then we just use construction 2p.
Oh, I see. Wait, does the thing necessarily work?
2p.
Yes.
So you're saying a
What
plus
is the
b
order
equals
of-
2p and a minus b equals.
Use Euler's for the y, and then
Yeah,
What
you
it's
don't,
just
you don't
fine.
have to worry about orders because it is definitely going to the right.
Yeah.
Alright, go down.
Oh,
Alright,
yeah.
then you do. So then you're doing
Yeah, that is
Are you solving a
simplified.
plus b and a minus b equals 2p and p?
Yeah.
So okay. Wait. Oh, p minus 1. Yeah.
Yes, P1,
Your
P
p
minus
minus
1.
1 looks like a p.
It's just my handwriting.
I mean, it's not. I don't think your handwriting is that bad. It's just your handwriting on 5x speed. I don't think same as your handwriting on 0.8x speed. Okay. Okay, so you're solving a plus b equals 2p and a minus equals p minus 1. Yeah.
Yeah.
Yeah, then
So that
just
means 2a equals 3p minus 1.
over 2.
So
Yeah, because like 2a equals 3%, so just like
yeah,
that's
and
by
then
2.
b.
The other two,
equals
yeah, if you're plotting a back into the
plus
equation.
Okay.
Yeah.
And then b is odd.
Hence,
Oh.
p is congruent to 1 mod 4. And then if you want to do the whole stuff, like KB, just anything, then 2k plus 1 is odd number. Let that be b. Yeah, then just times that by 2, both sides by 2, minus 1, and then you just 4k plus 1. As p, and then p congruent to 1 mod 4.
Wait, hold on. I'm a little bit. So, I feel like all of this kind of is motivation. Like,
Yeah, this is the motivation. If
like
you're writing like
as a proof,
you're writing the
I
proof,
think
you
for
just
the
write.
proof, you need to draw backwards arrows.
yeah, like the proof
Yeah,
you
just-
start at the bottom, right?
It just proves you need to.
I feel like for a
But
proof,
like, yeah, like
you just show 2p works. Like
Yeah.
you just show your
Yeah,
construction.
you just
don't
claim 2p for
I think
Yeah.
one
I
more
feel like
4p.
that the whole like most of it was just you figuring out that 2p.
Yeah, most of it was motivation.
Yeah.
You just need
Yeah,
to
I have
show
to
that
guide
it's-
the viewer through how how.
viewer now. It's not the listener.
It's
It's the viewer now.
No, in construction, you just present your construction like, I just got this magically, and then
Yeah, but you don't
correct,
exactly
you
have
get the
like a pedestal or high ground for criticizing people's presentation.
Yeah.
okay, but I don't present at
He wrote
5x
too
speed.
much. You just don't write very much at all.
Yeah, no, I'm happy he had the guts to present to us. Okay,
Okay, can I walk through G8?
walk through G8.
Yeah.
What? Wait, we're not done with this yet. I still don't
Oh,
get.
I'm done. Like, yeah, because p congruent to 1 more 4, and you can just easily do that through
The thing
algebra.
that people don't. So one kind of I don't know is like if someone decides, okay, well, I don't understand what he's saying, but I trust him, okay, and then it turns out to be wrong, okay, it's like the most annoying feeling. I don't know if you understand. Because it's like it's your fault for believing him, and then it's you're kind of wrong together. You know what I'm saying?
Okay, so that's why I put all my very detailed algebraic steps here, and I didn't skip over anything. Everything is clearly explained.
But see, like even checking that B is odd is a very strange, because like, is checking B is odd is sufficient? Because then like if you have to check B is odd, why don't you have to check anything on A? Like, is A and B that different?
No, because like here, because here we have to negative
that
3.
A and B are
Yeah.
co-prime and they're more than 1, and stuff.
Yeah, you probably have to check that they're more than 1 or something. Like, so that's pretty trivial to do.
Yeah. So to write a proof of this, okay. So this is a good solution, but it's not a proof, okay. So to write a proof of this, you would actually construct these sequences, yeah.
Yeah.
So a sequence for A and a sequence for B, yeah. And then you would show that they satisfy the property. Yeah. So is it enough that it's 1 mod 4? So you have a sequence of primes 1 mod 4, yeah?
Yeah.
And then you have these sequences for A and B, yeah? Is that enough? Like, yeah, like can you check that they're co-prime and stuff? Like,
Yeah. Yeah, because the this is done like here, and also yeah, and then we can also see wait and then like these other conditions, they require A and B to be co-prime. If they aren't co-prime, then none of this would work. So then we assume that A and B are co-prime. So then because of the fact that all of this is if and most of the theorems I put are if and only if statement. So then we can work from the backside without having to just double check or anything. It's Euler the ratio that they are if and only if, I think. Right.
The Dirichlet, you have no authority for Dirichlet. That's the
I read it in March.
I don't know if
like so Dirichlet's theorem currently cannot be proved in high school. That's kind of like but it's borderline. It's very close. It's like complex analysis is like the main hurdle.
Yeah, but like a lot of people quote that theorem for AMON, obviously.
No one sure, but this is unnecessary because the fact that it's infinitely many primes 1 mod 4 is already like it's more well known than Dirichlet. You know? But
okay.
no, I think you're gonna. No, this is not like you're gonna run into a lot of trouble in ATT if this is your approach.
Okay.
Because this is not a proof, you understand?
Yes.
So like
I could probably
like the merit that you achieved is probably like so if you had 7 points, you probably get 7 out of 7 for merit. You understand? But like for the proof, you might get like 2 out of 7. You understand? So that's a waste. That's a waste of 5 points because you had it and then you wasted it. You understand? It's kind of like solving the problem and just leaving the exam and not even writing it down. It's like, yeah, I solved it. It's like, people do that, that's fine. But you gotta understand that's what you're going in for, you understand? Don't go back and be like, well, why did I get 0? They'll be like, well, because you never handed me anything, right?
Okay.
You know what I'm saying?
Yeah.
So I still want to know, like, if it's very simple to check, like, I mean, that's the only thing that's bothering me, right? Yeah?
Yeah.
Like, show me that A and B are co-prime, and show me that, like...
A and B are co-prime by the question. Like,
see, this is a really annoying comment already, right? So you're not assuming the question in your proof. Like you've constructed the sequences for A and B, okay? All right. So then it should be directly verified that they're co-prime. You understand?
Yeah.
Okay. And then you verify. It's very simple actually. You have A and B. You don't even need to check that B is odd, right? That's you don't need to check. That's only in the other direction. You just need to check A and B are co-prime, and you need to check that it satisfies the equation, right?
Well, we do need to check that B is odd because at the start we did assume that at the start of our case we did assume that B is odd. So we need to we assume that B is odd, so we have to make sure that condition still works. Because this reasoning is from the case where B is odd, and we need to make sure that B is still odd after all of this.
We're talking in the wrong direction. So we're starting with an infinite sequence of prime, yeah?
Yeah.
And then we got an infinite sequence of A and B, yeah?
Yeah.
And we're checking that A to the B plus B to the B to the A is divisible by A plus B, right?
Yeah.
So to do that, like you don't have to check that B is odd. You just have to check the. I mean, yeah, maybe you might want to know B is odd to check a sign or something at some point. But you know what I'm talking about? Like I don't want to see it in reverse.
Okay.
Yeah. Or in some sense, I do want to see it in the reverse of that.
Yeah. Okay.
Okay, and it actually takes not much effort. Okay, so if there's a resistance to doing it, it usually means you're not able to do it. Okay, which is going to be a problem come Saturday. Okay.
Okay.
So could you try to show us in front? Like we all applaud you for solving the problem, yeah. But like show us the proof, and we'll be here. Like, if you have questions,
sure.
Let's write the proof together. Okay.
Okay. I'll probably just write it down on paper.
Just do it on the screen. Don't be shy. Come on.
I can't see everything that I write on the screen.
You can't see everything.
If you just zoom out and then you can understand. Like I can't really double check any of my assumptions. Like yeah.
Okay, how about I start writing it, but you gotta be aware that you gotta be able to write it. Yeah. I'm not saving you effort because if you can't do it, it's gonna cost you a lot. All right. Yeah, I mean it's not the first time I've seen this happen, right? Like people go into senior contests, oh, I solved the first 3 questions. I'm in year 9. You know what I'm saying? It's like, okay. And where's your honorable mention? Where's your honorable mention?
Wait, what? Someone claimed 3 questions and didn't get HM. I didn't get.
Okay, so
I
let
got bronze.
Yeah, but
I
that's not
claimed 2
HM.
questions.
let P and B
So I
are
claimed 2
sequence
questions and bronze cut was 2 questions.
of primes.
Or,
One mod 4, yeah? Okay. So you should probably like prove this exists. Or quote like the theorem, yeah?
Yeah.
So it is well known that there's infinitely many primes 1 mod 4. There's infinitely many primes 3 mod 4. Okay. And there's and those things are kind of, they are special cases of Dirichlet theorem, which says there are infinitely many primes, you know, m mod n if m and n are co-prime, but it's not necessary. Okay, to quote it is actually rather inelegant. Okay, does that make sense?
Yeah.
It's a very bad mathematical practice. Okay, it reminds me of when Edwin was trying to quote this Mihalescu's theorem to like, it was some really basic, to prove some real basic thing.
But Mihalescu.
Like it was so basic, it's like forgettable. It's like okay. Now define, yeah, an equals and then bn. So what did you define it as? A p plus pn plus 1 on 2, right?
Yeah.
An is 3pn minus 1 on 2. Yeah.
Yeah.
Okay. So now we gotta show. What are we gonna show? Yeah. It's very straightforward. And it's kind of like a computer is checking you, right? Yeah. So when a computer is checking you can't be like, oh yeah, inspiration. You just gotta prove. Sure, an is bigger than 1. What was the question even saying? An is bigger than 1, bn is bigger than 1. They're co-prime, yeah?
Yeah.
And was there anything else other than an to the bn plus bn to the an is divisible by an plus bn? Is that all we have to show?
That's the question.
Is that the question?
Yeah.
Yeah. See, like we're worrying about this stuff, right? Like, you know what I mean? Because everything has to be right for it to be right logically, you know? Yeah. So, okay. Is it obvious that an and bn are bigger than 1? So I guess pn is greater than 3, greater than 2, yeah? Or greater than 3 even.
Greater than or equal to?
Yeah.
Yeah.
So this is greater than what? 2. And this is greater than like 4.
Yeah.
Okay, so that's good. Okay, why are they co-prime?
Suffices to show 3p minus 1 p 3pn minus 1
Well, they're not co-prime, but okay.
What?
You mean aside from 2?
Aside from 2.
Okay, so why are they co-prime? Okay, so suppose like d divides 3pn minus 1, d divides pn plus 1, and we show that d divides 2 or something.
Oh.
Can you show that?
Oh, I know how to show it.
Yeah, how?
Suppose it's true. We know, let the common factor for both be some prime q. So we know that Pn is minus 1 mod q. Right? So, and we know 3Pn is 1 mod q.
Yeah.
And the only way that can be true, the only value that multiplies
Did you just change my D to a Q?
What?
Whatever.
Oh yeah, because I'm just.
Yeah, okay, fine. Yeah, so again, if you subtract 3 lots of this from that, right, then you get D divides minus 4, yeah?
I'm doing something similar right now. Something that
Well, I just. But. Basically, obtain micro. This 2 can't be a common factor of both. You obtain
Yeah.
and obtain and wait.
What is he saying?
Did you ignore what I just did?
Yeah.
Okay, I did what you were saying, but I didn't use Q instead of D after I'd written D, and then so I subtracted 3 lots of this from that, yeah? Then D divides minus 4, yeah? Yeah?
Yeah. That's not what that might.
Okay, so then if D divides minus 4, it's basically either like, 2 or 4, right?
Yeah.
But then you can show that, I think, you can show that PM plus 1 is not divisible by 4. Yeah? Because it's 1 mod 4, right? But D divides this. And this is equal to 2 mod 4, right? So D can't be 4, it has to be 2. Or 1, yeah?
Oh wait, yeah.
That makes sense?
Yeah.
So once you cancel the 2, the AN and the BN are co-prime now.
Yeah.
So Ryan, did you even actually do this check?
I think so, like, but like, but this was like a long time ago.
Oh, okay.
Yeah, I think I wrote it in the
Yeah, so I think your example is like typical of your age transitioning, okay? Because like at your age, it's the focus is on getting the ideas, right? Whereas when you get older, it's more about like making sure it's all correct, you know?
I think I basically just checked BN was less than
BN is less than P.
Yeah.
PN.
Yeah, and then
Oh.
and then BN is co-prime with BN. And then that's what it's co-prime with BN.
Press 5, but okay, so we checked those 3 things, yeah? And then this is the big boss, yeah? So I acknowledge I'm not doing anything special, yeah? I'm just basically showing you how to make your idea worth something to other people, yeah? You know what I'm saying? It's kind of like I took a diamond and I just polished it a little bit, you know what I'm saying? I'm not creating the diamond. You created the diamond, you know what I'm saying? Okay, so how do we show this? So we want to show that. So we got AN plus BN. So I'm just repeating what you're telling me, right? So AN plus BN we know is 2PN, right? Yeah. Okay, so then we want to show AN BN plus BN to N equals 0 mod 2PN, right? Yeah. Yes, also we also have AN equals 0 mod N, and here you might check that here's also Yeah.
So AN I'm going to have and then subtract that AN. Yeah.
No. So we got minus Bn. The Bn plus Bn to the An equals 0. Yeah, so this is something we want to show, right? And this is something we have as true, yeah? Okay. So I guess we don't necessarily have to have A and B plus B equals this, right? And then this is equal to, okay, now you can check that Bn's odd, okay? Because we only had 1, 2 and we divided it, so it's odd, yeah? So Bn is odd. And An is odd as well, yeah? The An odd as well.
Yeah, but the fact of AN is not
No, well, you could have gone the other way, right? So there's no reason why one of them's odd and the other one's not. Okay, so this is Bn, the minus Bn to the Bn plus Bn to the An. Let's go. We have Bn I think An is bigger.
Why? Then what? I don't know.
I thought you should care more about this because this is all just for you, right? I'm pretty sure Alex can do this. I'm pretty sure if I show Liam, he's not going to listen anyway. It's all for you. And Charlotte. Sorry, it just turns out that way. I'm not doing it on purpose. Alright.
What?
No, it's like, okay, so then you get this, right? Okay, and then that's Bn to the Bn outside of Bn to the Bn minus 1. Yeah?
Oh, yep, and bio.
Minus 1. Yeah?
Yeah.
Which equals Bn times 1 minus 1 equals 0 or 2 Pn. Right? That's simple, right? That's like the full proof. Understand?
Yeah.
It wasn't any longer than what you wrote, yeah? You know what I'm saying?
Yeah.
But there could be other reasons you're presenting. It could be for motivation and stuff. Then you don't have to just write the shortest proof or whatever. You know? But it seemed like you were trying to write the shortest proof, but then you were kind of not explaining your motivation or like in some weird way, okay? Yeah, so the problem with the prep problems is like when you submit your problems all in one go. So like the problems you have for all the problems are going to be in every solution. So whereas I like it when you submit one at a time, because then you can fix your own problem for the next one. So, because like if you have the same problem for 10 of them, do you make 10 comments that's all the same comment? You know what I mean?
But I doubt a person will make them like similar mistakes, especially considering a lot of problems are meant to be diverse.
I don't know that diverse.
They seem quite diverse.
3 of the algorithm questions were senior or
Yeah.
Okay, that was quite, yeah. Alright, do people online have any questions? Do people here have any questions?
Who's online?
Yeah, and another thing is, this is kind of weird, like in almost everything, it's like when you present something, like, people only appreciate what you present if they understand it themselves. Does that make sense?
Yeah.
Like in some sense they don't really care how smart you are. Yeah? They only care about how smart they are.
But
And if they can understand it, they feel good about themselves. Okay, that's just universal. You understand? So like the best talk at the I went to the ICM in Korea. Okay, where they give out the Fields medalists, and all these Fields medalists giving talks. Okay, but you know who was by far give the best talk? This was this Indian guy at Princeton, and the reason everyone loved his talk was because his talk was the stupidest, dumbest possible, commonest denominator possible of a math talk. Like he literally boiled it down to like, let's just chase this one number invariant, and the number's like 1.6, and we're trying to get it down to like 1.1. You know, like he skipped like all the hard stuff. Okay, literally made this whole story about proving how this one invariant they managed to prove the bound from like 1.6 or what I can't remember what it was even, but like it just went down to the so close to the actual conjectured value, and everyone was just like they were hooked, you know, because everything he said was trivial, like absolutely trivial. It was like year 6 level maths at the International Congress of Mathematicians. Okay, but that's funny because that's where I learned. You know that one trick that kept coming up where it was like, if you have a conic and you want to find the rational points, you join the you join the line. Yeah. So okay. So if you have like a circle, right?
Yeah.
X squared plus y squared equals 1, and you want to find the rational solutions, so x and y are rational,
Yeah.
right? What you do is you start at a rational point, so the obvious one is like 1, 0, yeah?
Mhm.
And then you take a straight line with rational slope, okay? And you intersect it with a circle, and that gives you all the rational solutions. Yeah, it's pretty good. And it came up in these like the last question in these maths Olympiads, like the Korean National Olympiad. Yeah.
So we have to prove it if they are to cycle.
Yeah.
Or just.
But that was like the hardest thing he said, and he's talking about like open problems here.
Damn.
That was the most difficult thing he said was a circle, and he was drawing a straight line with rational slope and intersecting on the circle. That was the hardest thing in his whole talk, and it was finished in like the first part of the talk. Okay?
What the?
Every other part of the talk, he was literally talking to like a primary school kid. Okay, and everyone loved it.
You have a recording of it.
Maybe.
Wait, how did you gamble your way?
Gamble at a casino, like
yeah.
$1,000 to buy his way there.
That's the most.
I stayed at the casino. The casino the hotel had a casino. The casino helped me pay for the hotel. Okay?